Hello and welcome back. If you follow the channel, you know that we started to restore a vintage HP 3968A instrumentation recorder in the previous episode. It has 8 tracks and is slated to go into our Apollo.com setup. It will be a stand-in for the original Apollo DSC, the 11-track instrumentation recorder that was aboard the command module. We remove remnants of some former inhabitants, trace the power supply fault to cracked connectors, clean the usual faulty HP switches, replace the dried out pinch roller, and clean the heads. Then we had an initial shakedown of the transport, listening to a calibration tone on the comment track. We also discovered that all of his track cards were of the more precise but lower bandwidth FM type, which is not a good match for our Apollo setup. Fortunately, while we were in the middle of it, our friend John Pumpkinhead showed up with an HP 3964A in tow, the 4-track version of the same instrument. And his unit had direct record tracks, which is what we needed. After we gave it a once-over and I made a makeshift pinch roller for it, I got it to properly record and play on the comment track.
Mary had a little lamb, little lamb, little lamb.
However, it still has gremlins, as the transport does not work in the reverse direction. So at this point we have 2 recorders that show some promise. Let's go one step further with the 4-track one and try to record some instrumentation data on it. As you'll see, it's a bit more involved than doing a simple audio recording, as you have to go through a track calibration procedure first. Let me show you how it's done. So the first thing you do is that you calibrate it, knowing what kind of signals you're gonna get. And I'm aiming for a 5 voltage signal from the generator. This is one of the major features of this instrumentation recorder. It has an internal calibration unit. It's controlled by the many yellow and orange buttons at the top left and the very important meter. Here I'm planning to record a signal from a signal generator, which I'll set for about 5 volts peak to peak. Before I hook up the generator, I'll use the internal calibrator, set it to 5 volts AC, and adjust the input control so the level reads 0 dB. Then I will record the calibrator tone and play it back while adjusting the output level so it comes back out exactly at the 0 dB mark. You have to monitor the channel 4, put it in peak to peak and 5 volts. So you have an input adjustment here, and you want it on, it's pretty touchy, on about 0 dBm on peak to peak. So let's record this. And this should record a tone. Okay. And now if I go back, ooh, that was strong. Now I should monitor the output and see what comes out. And it's way strong. I would have to turn the output level down, which I do here. Okay, it's back at 0. So now we're calibrated. So now I know that if I record an input signal of 5 volts peak to peak, the signal to noise will be optimized and I won't oversaturate the tape. I also know that the voltage level will be reproduced faithfully. We can take it out of calibration, input, and then now I can monitor the input and it's at 0 dBm, so it's pretty close to the optimum signal strength. So that's my generator. Okay, let's record that. And since we have recorded on 4, we can listen to it from the tape, from the voice one. Alright, so we have it. What I haven't done is I haven't calibrated the tape card to the exact tape that I have here. So there's a whole thing where you have to tweak the bias and the compensation so it's nice and flat for the exact tape that you're using. So I'm using the factory, which is 3M890, which is probably not what that is, but good enough for now. Alright, so now we're left with one fault, which is this not going backwards, and that's a pretty big fault actually. And it's not the capstan, it's rotating the correct way, it's just that this reel is not pulling hard enough. So this motor is not working as it should, is my guess. The reels always rotate in opposite ways. So this is the forward, and there's a supply here. It goes through one motor, then all the way down here to a current supply, and this is 1.2 amps. There is another current supply, which is 0.8 amps, which only goes in the second motor. This motor here gets 2 amps, 0.8 plus 1.2, and this motor gets only 1.2 amp, and they pull in opposite directions, and this one is going to win. When they do the reverse, they just switch the place of the motors and the way they wire it. Right motor, which is now here, still see the arrow is turned in the same direction. The left motor is now here, it still turns in the same direction, but now the left reel has the 2 amps and the right reel has 1.2 amps. So it's just a balance of the two, and one wins rather than the other. So either one of the current supply is not working, which I doubt because it's working in one direction now that I think through it, or one of the relays is not doing what it should do. So in order to debug that, I have brought out the current probe, tube-based instrument. So by the way, the HP428B current probe is probably the last vacuum tube instrument to leave the HP catalog. It is already in the 1963 catalog, which is the oldest one I have. The catalog with the coolest cover by far, I must say. Lo and behold, now it's 1986. I'm not sure that the cover design has improved so much, but our 428B is still in there. A run of over 23 years, not bad. And I'm getting some weird results. So that's the right reel. If I go forward, should be 2 amps. I need to push on those two. And I get 2 amps, and then I lose them. It goes to 1.1 amps. Now if I go in reverse, I should get 1.2 amps to it, which it does, and then it fails. It goes to 0. That is all very puzzling. I was trying to debug the current sources over here, Q3 and Q4, and they are on the power supply board. Fortunately, I was able to couple 2 extenders and put it over here, so that's Q3 and Q4. My first culprits would be the 2 transistors. I took them out, put them on the curve tracer, and they looked bizarre at first, but then I realized those are not normal transistors, they are Darlingtons. So once I knew that, they look fine. I also realized that when these run, they turn very, very slow, so I should run them at very, very slow speed. If not, I'm not going to get the current I want through them. So I rethreaded the whole thing. I am on the left motor forward should be 1.2 amp. Forward, left motor. 1.2 amp on the dot. Backward should be 2 amps. Try that, backwards. 2 amps on the dot. Okay, that starts good. Most of the current supplies do work. And so this is now the right motor forward should be 2 amps. 2 amps, right motor forward, right on 2 amps. Backwards should be 1.2 amps. 1.2 amps on the dot. And say what gives? Then I looked over here. And guess what? Now it works. So I'm not sure what I did, if it's the repositioning the board, taking the transistors in and out, unplugging the motors to check the impedance. But now it works forward. It works backwards. And I can change the speed. Faster. Slower. It repaired itself. We don't know what it is. Ha! I didn't repair anything. It's just that I was in the middle of the reel. That's where I was. Now it works. Hardly. Horizontal position doesn't help either. And, so it's a mechanical problem. Is there an adjustment for the force of the capstan that I would have to do? Yes, there is indeed an adjustment for the clearance between the pinch roller and the capstan. 0.76 to 0.97 millimeter. Just looking at it, it's like 3 or 4 times that. So that's likely part of my problem. Oh, and my capstan is ruined. I don't know if you can't see it, but it's bad. Yep, gone.
A little longer than a few minutes later.
Alright, I made an emergency pinch roller out of the old roller, which I cleaned up, and just electrical tape. While I sent a desperate email message to the people I know that can refurbish those. Right, looks like the new capstan and the new adjustment make all the difference. So now it's working a treat. It can go in that direction. Stop it. Go in the other direction. And now that I know that, I'll also adjust the capstan in the other one, because I bet you it's not adjusted correctly at all. Actually, the pinch roller, not the capstan. So sure enough, I have the same problem on the other drive, and I found out that the best way to adjust it is to remove the heads, which you can do by just unscrewing them, and there is no alignment required. You want that to be between 0.30 and 0.39. This is a 0.30. It almost goes through. It's a royal misery. You have to open this up. And there are 2 adjustments over here, but you won't see them. Okay, I found a way to get to it. It's completely inaccessible, and it's this guy over here. There we go. Okay, so now that works, but it's still not correct, because there's another adjustment you have to check, and I just checked it, it was completely wrong. Over here, there's a little pin right here, and you have to adjust it so the pin is free from this fork, so The spring controls the tension, and right now it's not doing it. No. So the pin stays in the fork and it should be out of it. And in order to adjust that, you have to go here. Alright, and then you move the entire solenoid. I'll put it somewhere in the middle. No. Okay, I finally got it to do what it should do. If you look at that pin here, there's a little gap between the pin and the fork here, which means it's riding on the spring. Okay. Alright, we got that adjustment correct. Now let's recheck that our capstan is correct too. Alright, 0.3 goes through. 0.40 doesn't go through. Okay, so now it should work. Okay, that should be the right adjustment. And another advantage is now that the heads are out, they are much easier to clean and degauss. I took advantage of that. And there's no adjustments of the head, you just pop them in place. And that's all there is to it, supposedly. Alright, I think we're done with the mechanical restoration. I think this will work. So here I have a nice demo. I have 4 test signals, a heartbeat from an astronaut, another heartbeat from another astronaut that has a problem, some frequency modulation and a ramp. And it actually mostly works except the channel where we have our voice. So here I'll be trying to record on the 8-channel unit, testing the first 4 tracks. It has the high precision FM cards, which can record very slow signals all the way down to DC, like the very slow linear ramp at the bottom. Starting at 80, record, go. So supposedly it's recording all my telemetry signals, my heartbeats, my frequency sweep and my ramp. Okay, I've done 20 graduations, and now I'm going to turn off all my signals, rewind, and since it's FM, it should be very precise replay. That's actually the preferred mode of recording telemetry. So let's do FM replay and see if it gets our telemetry back. And sure enough, there we have it. We have our astronaut heartbeat and the other heartbeat that's not quite right, the frequency sweep and the ramp. These 4 channels are working, and I checked these 4. Actually, let's check it. You will see that they don't, the last one doesn't work. So I'm going to do the same experiment and record the whole thing. And you can already see that the last channel has a problem. Pretty ugly, just passing the signal through. And that's not even the recorded signal. So let's keep that going. And play back. And you see I have channels 5, 6, 7, and 8 is gonzo. Okay, so we're going to maybe exchange those 2 and see if the problem follows the card. Let's hope for the best. Oh no! Oh no, I have the problem. I have a problem on 4, so it might be a head problem. So I looked at the recorder heads under the microscope and they look fine. I checked the continuity and it's 4.5 ohms and they are all 4.5 ohms. So head looks fine, which is good news. My guess is that there's a problem in the recording path and it's not due to the card, so it's in the wiring from the card to the head. So just to annoy, the channel 8 card slot is special because that's the channel where you can record audio comments. Unlike the other tracks, the FM card output is not connected directly to the heads. Instead, it goes through the voice card first, so it can temporarily splice in the microphone voice when you press the push to talk button. That makes the wiring way more complicated to follow. On channel 8, the card doesn't go straight to the head. The card, that's the record control circuit, goes to the backplane. Then from the backplane, it goes to this connector X8J1. Then it hits the card that does the voice control straight through to a relay. So the relay chooses whether you get the FM data from the card or the data from the microphone, and then it goes into a cable and it goes to the head. And the return is super complicated. Comes back from the head into the back plane, where it splits in two. One part goes here and one part goes there, straight through the record card to the back plane to another card where it finds the ground. On the other path, it goes in the FM card and comes back out and also finds the ground, which means we have to find where all those connectors are, but there is a connector map. Fortunately, former Kind and Wise HP give us the schematics and the location of all the connectors. The drill is simple. Start at the recording head, make sure we can measure its 4.5 ohm impedance, then work our way backwards. See if we can measure the impedance of the recording head at the various connectors, of which there are many. We will probably lose it somewhere. Okay, so we have the work cut out for ourselves. Thanks goodness they gave us the schematics. I can test here directly on the voice card, and conveniently there are the two last connections, and that should be connected to the head. Is it or is it not? It is. 4.5 ohms, which is, or 4.7 ohms, which is the same as I measured on the head itself. So the signals are the head come all the way to the voice card. Bummer. I thought we would find a fault right there. Alright, I read the hieroglyphics some more and discovered there's a mistake. They say it's J1, but that's not true. It should be J2. And the two extreme pins. Again. Okay, this is not the probe, this is the head. And it was 5 ohms, so it's still good there. The return, after it goes through the card, should be going to ground on pin 10. Similarly, the return from the voice card is on pin 2. And it is grounded. And nope, we didn't lose it. The head is connected all the way through. So maybe the fault is on the voice card? There, the FM signal should normally make it straight through, albeit going through the voice relay. Maybe the relay is bad and the signal does not go through the card? So on the voice card, the hieroglyphics tell me that, just shut up, that it's the signals from the FM card comes from this side here and goes to here. It does. So the circuit appears complete between the record head and everything. I was starting to suspect that it has to be a bad contact with that guy, so maybe reseating it. I should be able to record with just... I shouldn't need that. If I understand my hieroglyphics correctly. Hello test 1 2 3. Hello test 3 2 1. It worked.
Hello, test 1 2 3. Hello, test 3 2 1.
All right. Okay, so it was a bad contact on that card. And I bet you now if I do the other card it will work. Okay, we're going to try to give it a go just with that signal. I should just go record. Stop. I heard it. And then now we're going to turn that off and do a playback. Here's the data, and you can hear the FM. So we repaired it. It was just a this card was not making good contact to the record heads. And okay, so Eric, witness this feat of engineering. Oh, it's not a feat yet. All right. So I'm recording 4 signals: heartbeat of an astronaut that's in good health, a heartbeat of a W's astronaut, a sweep, and a ramp. And this is the FM, so you can go as slow as you want, so that's a more precise one. And you can say, you can go in, this is the end of the recording. Okay.
And that actually replaces the 4th channel.
Yeah, so that's on the 8th channel, that's the one that was causing me trouble.
8th channel.
And now you go back and replay it. Or you hear the FM, right? There you go. And here's your telemetry back. So, and I tested all the other channels. So I have 8 channels of working telemetry FM. But that's up to, no, that's more precise, but that's up to 3 kilohertz. So that's not the one we can.
This is the end of the recording.
Alright. And the transport works. Oh, and then you can, of course, the most fun is to sing into the thing, and then you change your voice, right?
Or play it backwards.
You can play it backwards at different speeds.
Hello, test 1 2 3. Hello, test 3 2 1.
In the Klingon direction. Okay, I can speak Klingon. So I've hooked up the 4-channel instrument. The 4-channel instrument has direct channels, very much like a traditional audio recording. It's much higher bandwidth, up to 64 kHz at the fastest tape speed. However, the lower limit is now 100 Hz, so I have to speed up my ramp quite a bit. 4-channel telemetry recording trial number 1. And yeah, it's working. That's all for today, folks. Okay, and then we go back. Yeah. Okay. Okay, a little bit more.
Channel telemetry recording trial number 1.
Yeah, so I have my high-speed High-speed direct recording here.
That's all for today, folks.
Alright, and actually with the Apollo setup, we'll have to get it at 15 inch per second. But okay, but anyhow, we have our flight recorder tips working.
Hello, test 1, 2, 3. Hello, test 3, 2, 1.
In the Klingon direction. Okay, I can speak Klingon.